Hello everyone. So today we will going to solve a problem called better string. So let's see the problem statement. Given a pair of strings, Geek wants to find a better string, and the better string is a string having more number of distinct subsequences. If both the strings have equal count of distinct subsequences, then return a string 1. So what basically this problem is saying that we have two strings, okay, string 1 and string 2. We need to calculate the distinguish subsequences, okay, and whomsoever this distinguished subsequence count is greater, that would be our answer. If in case if both are similar, like if both the count are same, then return the string 1. So here as you can see, for this string gfg there is 7 distinct subsequences, whereas for string 2 4 distinct subsequences. So our answer is string 1 gfg, right? So this is our answer. So this is the thing, and the expected time complexity is O of n and auxiliary space is O of n. So that is the whole scenario. So first we will going to see what is subsequence. Subsequence is a sequence where the order of the characters is remain same as it is in string. So what I'm saying here is, so as we can see, these are the possible subsequence of the string AC. So an empty string is a subsequence, A is a subsequence, AC is a subsequence, and C is a subsequence. So as you can see, the order of A is coming first, right? Here it is also coming first, here it is also coming first before C, and here the C, okay? So as you can see, the order is remain same. Now coming here, is CA is an subsequence? So answer is no, it's not, because the order is not same, right? So A is occurring after C, so that's not the case here, right? So now the total number of possible subsequence of a string would be 2 raised to the power n, where n is nothing but the length of the string, okay? N is the length of the string. So in that case, length is 2, so total number of possible subsequence will be 4, right? 2 to the power 4, 2 to the power 2, that is 4. Now, coming back to the question, what it is saying that we need to calculate the distinct subsequences, okay? So number of distinct subsequence. So when I'm saying here is the total number of possible subsequences 2 to the power n. So, but it might be possible that redundant subsequences can also occur in this 2 to the power n solution, right? So we need to filter out the distinct number of subsequences, right? So let's see this case, okay? So let's say we having a string AC BC, okay? So this is a string. So ideally, the total number of substrings can be 2 to the power 4, which is 16, right? Ideally, it should be 16. But in the 16th subsequences, there might be possibility that a redundant can occur, right? A redundant can occur. So we need to filter out that, right? We need to filter out the redundant one, okay, repetitive one. Okay, let's see. So how we can approach. So there is this is a method, another method in order to write down the subsequences. How we can write down the subsequence? Let's see. Okay. So here, let's say if we have a empty string, right? If we have an empty string, so then the number of subsequence possible subsequence would be empty, right? Let's say if we have a string A, so what could be the possible number of subsequences? So it would be an empty string and A itself, right? So when we have AC, right, we have AC string. Okay, if we have AC, so the possible subsequence would be empty string and A, C and AC. So these many are the subsequences, possible subsequences when we have a string AC. So how I have written it here? Let's see. So when it is C, so all the all the subsequences which occur with A will come falls under C automatically. So as you can see, this is the solution that I have just copy pasted from the previous one. Now for another new subsequences, one it will go with this empty string and form C, and then this C will go with A and form AC, right? Now comes to B. So for B, I have copy pasted the number of subsequences occurring till AC, right? So this is present here. Now for B, it will start interacting with the previous one. So with empty string, it will form a B, right? With A, it will form AB. With C, it will form CB. With AC, it will form ACBC. So it's total 8, right? Okay. So far, do we have any redundant one? As let's see here. Do you have any redundant one? No, we don't have any redundant substrings. So when I'm saying redundant, so there is no repetitive, right? So yeah, we are good. Now let's come here for C, right? As we can see here, C has already occurred, right? C has already occurred. So let's see the possible solutions. Okay, so we will copy paste till B, so it will automatically come here. Now for C, first it will interact with this empty, it will form a C. Then it will interact with A, it will form AC, then ACC, then ACCC, then these many. But you can see this is the final solution. This is the final solution. In the final solution, what we can see here, that C is occurring twice. So this one is the redundant. So this should be eliminated from our output. So this is eliminated. Now this AC is also redundant. So this is also eliminated, right? So ideally the total count would be 2 to the power 4, right? Till here 2 to the power 4, which is 16. But our answer is 14 because two solutions are redundant. So I have eliminated those two. So 14 is the correct answer. So when I'm saying the total number of distinct subsequences for string ACBC, so answer is 14. Now, the code wise, how we will find out the number of redundant one. Okay. So as we can see here, if we can remove the occurrence of AC, number of occurrence of AC from the string, we are good. Then right. So when this AC had formed, so when we see that AC have communicated with this empty string, then they have it formed the C. So here the redundancy arises from here, as you can see AC. So when it is formed, when it is communicated with this empty string, then it forms C, and then when it have communicated with A, then it forms AC. So I can say that if we can somehow find the occurrence of this number of subsequences, that is 2, then we are good, right? We can easily remove, right? So yes, what we will do, when we go with when the C have already occurred earlier, so we will say that okay, ideally it should be 2 to the power 4 is the answer, but we will see that previous occurrence of C. So previous occurrence of C is here, and we will look, it's just previous count, so it is 2, right? It is 2. So we will remove 2 to the power 4 minus 2, right? Then it will be our answer. So that was the whole approach. Let's solve this problem. Okay, so here what I need to calculate, I need to calculate the total number of distinct subsequences for string 1 and total number of distinct subsequences for string 2, and then I'll check which is greater, then I'll return my solution. So for that, let's create one method called distinct subsequence, right? And it will take a string as an input. All right. Okay. So it should return some answer, right? So ideally, we know that in any scenario, let's say we have a number of string as 1. Number of string is empty. Let's say we have an empty string, right? So in any scenario, the minimum number of subsequences would be 1 in any scenario. Okay. So let's say we have an empty string. So what is the number of subsequences? It's 1, right? Okay. That's it. So let's say we have count answer. So it will always be 1 because as we know that total count of the subsequence in any scenario would be 1. Okay. Now let's create an array of integers. Okay. And its size would be 26. And fill this array with 1 minus 1, let's say. Then what we will do, we'll iterate the string that we have given here. We'll iterate the string. We'll iterate the string and we'll check that if array of that character is still minus 1, we have not put it anything, right? So then what we will do, we'll store the previous count. Okay, so I'm saying that array of str dot caret I we store its value as count. So we are storing its previous count, right? That's why I stored count. So for example, we have ACBC. So for ACBC, when we go for value of I, that is A, right? If we go for A, then we need to store the value of its previous count, right? That is for empty string, that is 1. That's why I have put it count. And then also, as we know that our answer is count into 2, right? For A, we have two subsequences, that is uh, empty and A itself. So we did this. Let's say we have not null. What if we have not null? So it means ACBC for C. Let's say we went to C, right? So it's already occurred, right? What I said there, I said for C, I need to go to this previous count and I'll take its previous count and I'll subtract from the total count, right? So what I said, I will go with, let's say we have a temp, we'll store its previous count, and how we will find the previous count, we say array of str dot char at I minus a, so that will give you the count of its previous occurrence. And then I say that okay, update the value because it might be possible that in later part we have some another occurrence of C, right? So we'll update the count, and as we know that our count is actually into 2, right? It's not the count because here we are storing the previous count, right? But in actually it is multiplied by 2. And then I said the count would be count minus temp, that is previous occurrence count, right? That's it. So when this loop completed, I will return the count, and here I will say that int count1 for string 1 will be calling this method distinct subsequences. Let me copy paste this because usually we make mistakes. So yeah, here we will pass string 1 and then int c2, which will again call this method, and we'll pass string 2. All right, so when I'm saying that return if saying count 1 is greater than equal to count 2, uh, return str1, right? Or else return str2. That's it. Let's try to compile and see it is working or not. Okay, so here we need to, here I have missed this thing. All right, So it passed completely, and now try to submit and see what is the uh, it will pass. Yeah, it's passed. So now let's discuss the time complexity of this problem. So here what we are doing, we are traversing n times. All right, we are traversing the n times. So the time complexity is O of n, and we are storing the value let's say it's ideally O of n. Okay. So but we are using a variable of fixed size, so we can say O of 26, which is O of 1, I guess. Yeah. And so total time complexity is O of n. That's it. uh, we can solve this method usually whenever you have asked this question in interview. Do not jump to this problem directly. The first approach will always be find the all possible distinct subsequences count using recursion, and then return the answer. But the thing here is it will take 2 to the power n times, right? So which is not expected here. So yeah, thank you.